Good day, everyone. Thanks for turning into listen to my presentation. My name is DinhHoangViet. My project title is Exploring Printing Parameters Factor in 3D Printed Honeycomb Sandwich Structure. So the next slide will contain introduction, background, aim, and objective, literature review, methodology, result, and discussion. For the introduction, what is a honeycomb structure and what is additive manufacturing? For the figure one, this is honeycomb structure. The honeycomb structure is made up a number of hexagonal cells that are connected together to form a solid structure because of its excellent quality, like lightweight and low cost. And this form is frequently used in engineering and manufacturing. The honeycomb sandwich structure can achieve a high material utilization efficiency and reduce structural weight under condition of meeting the design requirement of strength and stiffness. Therefore, it is widely used in aeroplane, regency, shipbuilding, construction industry, and the honeycomb sandwich structure typically consistent of two-phase ship and honeycomb core. This is a two-phase ship and the middle is a honeycomb core. The common phase ship material usually is aluminum, stainless steel, glass fiber, reinforced plastics, and composite material. The typical honeycomb core including the paper honeycomb, metal honeycomb, and no-mix honeycomb with the continuous exploration of structural lightweight. The design concept of all the composite sandwich structure with the honeycomb core has been proposed. So the next one is what is additive manufacturing? For the figure 2 is the 3D printing machine. Additive manufacturing is a fabrication method that create the 3D form via the accumulation of material coupled with computer. This design is called CAD. Additive manufacturing have been popularized in rapid prototyping and customized design solution. For the next slide, I will talk about the background and the benefits of honeycomb structure. A sandwich honeycomb structure is a special form of a limited composite formed by two stiff facing at the top and bottom, high specific strength and stiffness, and moreover, it is a lightweight. So for the figure 3 is the honeycomb sandwich structure. For the top and bottom is the face shape. For the middle is a honeycomb core. So the next one we talk about factor affecting the 3D printing process. Various factors such as printer processor, process parameter, material composition, and post-processing affect printing product with mainly manifest in accuracy, processing time, and material properties such as ultimate tensile strength, elastic modulus, yield strength, and impact strength. Printing factor in the honeycomb structure such as layer height, printing speed, temperature, and honeycomb shape. For For the layer high is referring to the thickness of each layer of material deposited during printing. A lower layer high result in a smoother print, but it takes a long time to print. A honeycomb structure is with a few layers has a smoother surface and it is stronger. However, it will also take a long time to print and may be more prone to deflect. For the printing speed, the printing speed of 3D printer is the rate at which material is deposited. A faster print speed will result in a faster print, but it may also got a lower quality of print. A faster printing speed honeycomb sector structure may have a rocker surface and be quicker. For the temperature of the printing bed and it should the nose can have an impact on print quality. The appropriate the temperature will differ depend on the material being printed. For the honeycomb shape, the honeycomb structure shape can also affect the quality. A honeycomb structure with the regular shape will be stronger and easy to print. For a honeycomb structure with an irregular shape, on the other hand, may be more difficult to print but may perform better and in certain application. For the M, an objective for the M to determine the printing parameter factor on the mechanical performance of the 3D printed honeycomb. For the objective, I will determine the 3D printing parameter via literature study. And the second one is identify the selected honeycomb structure. For the third one is conduct the experimental study on the mechanical performance of the 3D printed honeycomb samples. For the next slide is a Gantt chart for pack A. The Gantt chart for the pack A for the first week, we go selection the project. The week 2 week in Unity Station, the project. For week 3 and week 4, we do the introduction and the background. For the week 4, week 5, we go do the project aim and objective and scope and limitation. For the week 6 to week 12, we go the literature review. For week 7 to week 9, we will design the harness. We will go short form methodology, and with 9 to with 12 we go to design the honeycomb structure. And for this week we're gonna go the presentation. For the next slide is literature review, printing parameter, infill densities, printing speed, nozzle temperature, bed temperature, and this figure 5 is printing parameter. For the printing parameter, we have a printing head. This one will move along the X and Y direction or the plane and guide to the form the path cross section. For the issued multiplier flow rate is referred to slicer setting that determine the amount of plastic to the extrude. For the layer height, layer height is the thickness of each layer of filament that is extruded by the nose and deposit on the view place. For the node temperature, the hot end must heat up the tip of the solid string of filament until it is propellant enough to fall through the nose and onto the printing bed. That's all. For the next slide, I go the methodology flow chart. I will start at the literature review, and after that, determine the printing parameter and identify the honeycomb structure, and move to create the 3D printing file and convert it to STL file. So after that, we go to 3D print, and if the quality print not acceptable, we create and we print. If the printing quality is acceptable, we go test experiment and data collection. After that, we will analyze the data. We have been collect and give some conclusion and recommendation for the result. This figure 6 is a honeycomb structure. I have been designed by using the SolidWorks, and after that I will convert it to the STL file. And as you can see, the length of a honeycomb structure I create is 130 millimeter, and the wide is 35 millimeter, and core thickness is about 10 millimeter. So in this step, I'm gonna use the 3-point bending test to determine the flexural property of the honeycomb structure according to the ASTM C39300 to test the honeycomb structure. So the next slide is planned for FYP, PACP, prototyping, data collecting, report writing, and Gantt chart for PACP. And that's all. So thank you for listening my presentation.